Let's do some more cybersecurity terms recap, part 2. Okay, let's talk about some important things, especially cloud-based firewalls. Let's start off with that. So cloud-based firewalls, the firewalls can be software firewalls, you can have hardware appliances and so forth. These are software firewalls because they're of course hosted by the cloud service provider whose main job is to filter packets, right? So firewalls stand as a bastion between a threat actor or a threat packet in this case and your devices, your content, right? Your other any kind of application, your service, whether they're public facing service or intranet service, doesn't matter, but you need a firewall to know that you're not being, that you know what's coming in and to make a quick check before you let them in. That of course brings us into cloud computing. So cloud computing is a long time ago. But when we used to do network diagramming, you used to draw a cloud to show that this is a remote connection, and that now became cloud computing. So it's a practice of using remote servers, applications, network services that are hosted on the internet instead of a local physical device. So if you say my database is on the internet, you show that there's a cloud-based connection. So you're connected via a cloud to a database icon or a stencil that you can use. And similarly, what's a cloud network? A cloud network is a collection of servers or computers. So think of it, a network of things, but that is on the cloud, right? Which means it's remote and via the internet, that stores resources and data in remote data centers that can be accessed via the internet. And this, if you consider what you have on Google Drive and so on and so forth, or OneDrive, all examples of cloud networks. When we're running our AI chatbots, they're basically using cloud networks, right? It's a collection of servers or computers that store resources and data in remote data centers. Then comes something called a control zone. What's a control zone? A control zone is nothing but a subnet. So you can split a single network into smaller sub-networks. A sub-network is called a subnet that protects the internal network from the uncontrolled zone, right? So what you're doing is you've got the general network, and then a subnet is basically as if you're creating sanctum sanctorum, right? Your own sanctified place that's much more difficult to access. So you can create better security around it, a better perimeter, so we call it network perimeters. You can build a better perimeter, but in order to create that, you create a sub-network that is a bit more robust than the general network. So in order to enter the sub-network, you have other kinds of access controls and identity controls, identity management and access management and so forth. Then comes a data packet. So we've talked about it a little bit, and so all data is broken into packets. Once upon a time it used to be circuit switch, which meant that, perfect example is a long time ago when you used to make a call. If somebody were calling, no other call could get through, right? You wouldn't know anything that's happening. Is somebody trying to call me? You don't know, because that would be a circuit switch. A single circuit would either be a 1 or a 0. If it's 1, which means it's occupied, there's no way to access it. Today, of course, or after a long time, or a long time ago, the circuit was switched into packets, so everything was broken into packets, and these packets were sent, right, as bits and bytes across the network, which meant that you could now do multitasking. You could actually, while taking a call, see that somebody else is calling you. You could check your messages. You could get on your Discord server. You can search the internet. You can even watch an online video if you wanted to. And you can of course know that there are other people who are trying to call you. So that allows, so packet switching allowed you, so of course data therefore has to be broken into packets to be sent across the network. Then is something called denial of service attack, or which is a DOS, or distributed denial of service, which is DDoS. So it's nothing but a distributed or an attack where all they try to do is it floods. So assume you have a door that can accommodate 2 people at a time. What happens if 300 people try to dash through it? Nobody gets in, right? It becomes a proper stampede and stops anybody else from getting in. So that's an example of, so nobody's able to get in, which is when you say getting in, it's accessing a network or accessing a web page, accessing a particular content. So you're denying service by overwhelming the system, by flooding it, deluging it, right, with network traffic. What's a DNS? Very, very important. A domain naming system. It's a protocol that translates internet domain into IP addresses. So you might have an IP address, let's say www.theworld.com. But www.world.com is just verbal translation internally. They all have IP addresses, which can be IPv4 with 4 octets, or IPv6, which is much more of an alphanumeric setup that accommodates many more. So DNS's main job is to convert, if it's IPv4, it might be something like 192.137.2.38. Now, that would be very difficult to remember, but it's much easier to remember www.theworld.com. So that's what DNS does. It's a protocol that does that translation from the name, which makes much more sense, easy to remember, into IP addresses, which is actually how the backbone naming convention works. Then we get into something called encapsulation. What is encapsulation? So encapsulation, so think of it, encapsulation is very much like enveloping, like an envelope. So what it does is it encapsulates or puts it inside a capsule or an envelope, a process performed by a VPN service, right? So virtual private network, where that protects your data by wrapping sensitive data in other data packets. So what it's doing is it's encapsulating. So think of the medicine in the capsule as being the very important data that you have, and the top of the the soluble piece of the capsule, the top of the capsule are these other data packets that are used to hide the sensitive data, and that's what VPN does. So that's why it's very important to sometimes have a VPN connection ready and running, so that you don't have to worry about other people sniffing, or it's much more difficult there. So encapsulation is very important, and oftentimes VPN services are good at encapsulating. FTP, or file transfer protocol, and this is again a protocol, but it's a protocol. A protocol is nothing but a series of specifications that are followed in a process, right, to do something. So think of it as a specification-based workflow used to transfer files from one device to another over a network, right? So what kind of, how do you move files? Once upon a time, you could set up these FTP connections. Internally, we still do that. Now we hide it in much better UX layers, but that's oftentimes used to transfer files from one device to another over a network. So when they say upload a file, oftentimes they might be using something like FTP in order to upload a file. Then, of course, is the very famous thing, a firewall. What is a firewall? We quickly mentioned that. We talked about cloud-based firewalls. So it's a cybersecurity device that monitors traffic to or from your network. It therefore looks at every packet, and it says, okay, this, allow it, that, allow it, that, don't allow. Looks suspicious. Don't allow somebody to go to this site. Don't allow somebody to access system to and from, including making sure that if there's something like a ping of death, a ping is nothing but a data packet or a series of data packets that are being sent, right? And oftentimes you'll see, you will use, oftentimes pinging is basically just sending a small set of bits and bytes to an IP address to see what are the steps they're taking to reach it, to see if it's active or not. So, of course, firewall's job is to make sure that only the legitimate ones, but of course that's where what hackers do, they try to masquerade themselves so that they look legitimate to enter the system. What's a forward proxy service? So proxy servers are important. A proxy server is servers that regulate and restricts a person's access to the internet, right? So because it's a forward proxy server, right, it tells you where can you go forward. So it tells you, so the proxy server might have a blacklist. These are the sites you can't visit, right? So all they're doing is they're controlling your access to the internet. Companies commonly have proxy servers, and so that you don't waste your time doing things or don't visit places that might act as threat actors, have or drive-through malware downloads or something, or drop-ins or something like that, or any kind of droppers. And then comes something, of course, we know, hardware. These are the physical components of a computer. CPU, GPU, of course, nowadays you hear about graphics processing units all the time, because they can, to a degree, do many more parallel pieces. RAM is random access memory. This is memory that gets things, runs it very, very quickly because it's very closely located, and then forgets it, right? So random access memory. And versus ROMs, which are ROMs and PROMs. You see that especially with logic controllers and so forth, where these are programmable memory bits, but they are you sort of code them to do something so they don't disappear. Motherboard is nothing but the general circuit that's set up on a board, which shows all the connections. Logic controllers, they tell you what to connect, who to connect, how to connect. Wi-Fi modules, there are many different modules, whether you're talking about Bluetooth modules. These are all the physical components of a computer that make up its hardware. What's a hub? A hub is nothing but a network device that broadcasts information to every device on the network. So it's a hub. Anything that comes in goes out. So it doesn't matter who it's sent to, everybody receives. So think of it as a megaphone of sorts, right? So anything that is spoken to the megaphone is sent out to everyone. As you move forward, you can go into switches and bridges and so forth, and routers, which then they don't broadcast information to every device, but only to specific devices with specific IP addresses, so that not everybody knows that. Then, of course, is something called a hypertext transfer protocol, which you see that HTTP is an application layer protocol, right? So this is right on top of, nearly on top of the OSI stack. That provides a method for communicating between client and website service. So HTTP is what you typically see on a website when you visit. So it's typically HTTP or HTTPS www.theworld.com. So it allows you to communicate between client. Client is the one who's like what we're looking at oftentimes, whether it's your tablet, your smartphone, your laptop, and the servers are where the information is stored, which is serving us the information. And of course, HTTPS is nothing but a secure shell layer. It's nothing but a secure method. Nowadays, of course, you find that a lot of companies have HTTPS connections, which basically means it's a secure. Simply put, means that your information has been encrypted prior to passing through that particular channel, right, to keep you safe. More next time. Thank you very much.